Welcome to Build 2023 AI Pillar. Wanted to talk to you today about some of the things you saw at the keynote, hopefully a little bit ago, around what we're doing with the Windows AI developer experience and how you can make this easier, whether you start with Windows AI app-enabled apps or whether you start with iOS, Linux, Android apps and can easily move them back and forth using the ONNX Runtime inference engine. So today we're going to talk about how you deliver AI-powered experiences across cloud and edge with Windows. I'm Jeff Mendenhall. I work on the AI platform team at Microsoft. I'm a technical program manager and product manager responsible for hybrid AI within the AI platform and including how we work with Windows. So we're going to talk about a couple things. One is hybrid loop is now a reality and how we're going to use ONNX Runtime to enable that. Really go through a demo of the end-to-end developer experience using the Whisper model as an example, and then looking at using DirectML EP in conjunction with ONNX Runtime through demos. So I'm going to show you, or we are going to show you 6 demos to highlight what this is. And then hopefully we'll have time for a little bit of Q&A. So the key part is a year ago at Build, Satya and Adele announced the hybrid loop development pattern. And what this really meant is within Windows, how do we make it so it's easy to do cloud inferencing, local inferencing, make the choice up to the developer, but also add toolchain in so that for you to optimize and really get the power of AI on each different hardware platform, that you don't have to know all the intrinsics and all the details. So we introduced Olive, which is part of the ONNX toolchain. So it will allow you to take a configuration file in a PyTorch or ONNX or other model, add a configuration file for Olive to it to tell it, hey, what are my production requirements and what hardware accelerator do I want to use? And it will produce a package. That package is going to have sample code. It'll have the optimized model for the hardware that you wanted it to be for. It will have the right execution provider, which I'll talk about in a bit, which is really a hardware accelerator. It'll have the ONNX Runtime binaries that you need. It'll have sample code to allow you to easily integrate it into your app. And again, so this gives you how do I create or take a model and optimize it for my hardware that I want without having to worry about knowing all about it. It gives me a cross-platform, cross-silicon, cross-cloud and edge inferencing engine with ONNX Runtime. Don't care if it's Windows, Windows on ARM, iOS, Android, Linux, it supports it all. And it makes you able to take a Windows app that has ONNX Runtime and move it over, or take an iOS app that's ONNX Runtime enabled and move it over to Windows or one of these other platforms with very minimal code changes. And that is the goal. How do we make it easier on the developer experience so wherever you're making your investments, it's easy to expand them elsewhere? The other thing we announced is Azure Execution Provider for ONNX Runtime. We announced this a year ago, Stevie Patish, one of our technical fellows. How can we do that to really power this? And so what we've now made real, and again, everything you see here today, we're going to have a QR code at the end, but you can also go to onnxruntime.ai. You can also go to onnxruntime.ai WAC build 2023, all lowercase, and it will actually give you a list of the code repos. It will give you a list of different blog posts that will expand upon all this. So this is what we announced a year ago. It's all product truth today. So for the Azure Execution Provider, and again, think of execution providers as hardware accelerators. In this case, we give you a single API where at runtime you can determine whether you want to call the cloud or you want to call one of the local pieces of silicon through which execution run, whether it's an NPU, whether it's a CPU, whether it's a GPU locally. So you can decide based on the experience you want. If I want super short latency, I want to use local. If I want a rich, expansive model, I might want to go to the cloud. If I lose connectivity, well, then I just use local. That way you get to control the experience and what you want. So ONNX Runtime, really, I mentioned cross-silicon, again, across every CPU type, GPU type, now introducing NPUs or neural processing units that have just been announced, some of which you're going to see up here aren't even on the market yet. But ONNX Runtime is already enabled to run across all of them today. And when you switch between them, it's a couple to minimal lines of code to make that change to switch execution providers. And as you port it to different platforms, you're just recompiling your code on the different platform. It's made to be just that easy. So what are we announcing today? One is we have a whole slew of different execution providers. One, I mentioned the Azure execution provider, and again, these are all public preview, and you can find them today. Actually, you could find them yesterday. QNN from Qualcomm for their neural processing unit is live. OpenVINO for Intel's VPU or NPU-like device is also live. The Vitis AI from AMD for their Ryzen AI platform, also live. DirectML has been live for years, and DirectML is an interesting case because it allows you to actually abstract above the GPU hardware today across all GPUs on Windows, so you can only optimize it with Olive once, and then it works across every GPU on the Windows platform. And eventually what it's going to do is it's going to cover all NPUs as well. So again, if you want to make it that easy, I optimize once, works across anything on the Windows platform, any silicon effectively. And gets the goodness of still the transportability with ONNX Runtime. We're also working on a WebNN so that you can continue with WebORT that exists today, so I can do local inferencing in browser. We're also implementing the WebNN standard, and we're working with Intel, so once all of the code changes get approved, it's coming soon at this point. Now, I'd like to show you the demo. Go ahead and cue that up. Of Stable Diffusion working on Qualcomm's QNN EP. It's actually running on the Windows Dev Kit 2023 that we announced in October. So here's the prompt that we're running. I'll let you read that. But again, this is running on ONNX Runtime with a QNN EP on the Windows Dev Kit 2023. And as you know, if you've played with Stable Diffusion, some of these models, they're very hard to do local inferencing unless you have a pretty beefy GPU. This is running on the NPU, which is super energy efficient and completely offloads from the CPU, which you'll see examples or proof points of later in the other demos. So I've run this. I gave it my prompt. It's now generated my image for me. And yeah, as you can see, yes, it's available on ONNX Runtime. So now, one other demo, go ahead and cue that up, is going to be hybrid photo classification. So hybrid between client and local, or client and cloud on the AMD's Ryzen AI. And so we're taking an object model, or object detection, face detection model, and again, we're going to go between cloud and local. And we've also used the Olive toolchain, again, to optimize these models for the Ryzen AI platform. So I'm going to browse locally. I just got back from vacation. I'm going to load them all up. Now, in the first example, I'm going to do this in the cloud. So realize it's going to take a while because what you're seeing is transit time across the wire from my local PC up to Azure. So that's going to take a little while, but again, if I want to have that richer experience, or if I have all my photos in OneDrive, you're going to reduce the transit time, so it's going to perform about the same as locally. But again, I can do it. I've run it through the models. I now have face detection, and I can see where are the people. I can look at, hey, what photos have a tennis racket in them. Again, this is all run in the cloud right now, and thinking of the Azure execution provider, as I turn off my Wi-Fi, I can now restart the app and run it locally. And actually, I don't need to restart the app. I just turn off my Wi-Fi. Again, I load all the photos, load them. You'll notice it runs very, very quickly. And again, this is all on the neural processing unit, so it runs with almost zero CPU. It's all offloaded on the NPU, which is made for AI workloads, so it's extremely efficient and fast. So it just gives us that much more capability. Flexibility, as I mentioned here, hey, really the privacy and security where you want it. I want to keep my information locally. I have that opportunity to do that. And again, I get to decide at runtime if that's what I want to do. So why? Why is this important? Why do you care? I've got a ton of different frameworks of where I can train my models. And I have a bunch of different silicon and different hardware makers and manufacturers and a bunch of different platforms that I want to run them on. So if I have to take PyTorch or TensorFlow or ONNX models and run them across 20 different hardware variants, I have to tune and create code and everything for all of those different platforms. That's painful. That's a horrible developer experience. I'm probably not going to do that. It's going to be way too much time to do as well as maintain. So that's why ONNX. ONNX is a standard. It allows me to, as a transport or an intermediate model model standard. So I can go from PyTorch to ONNX, ONNX back to TensorFlow, and I can transit models that way. The other thing we've done, and by the way, ONNX is an open source community, as is ONNX Runtime, and it's been around for years. ONNX Runtime was created to then take these standardized models and be highly performant across all these different silicon. And as I mentioned, we have these things called execution providers, which allow us to perform optimally across the different hardware targets. And the last thing I mentioned we just added is Olive, which says, okay, now this is the last layer of the cake we were kind of missing, which is, hey, if I want to get the best performance across all this different silicon, and I want Olive to optimize my model specifically for each different piece of hardware. We can now do that, and again, it generates a package that you can then take with sample code in C#, C++, or Python, and you can plug that code in with minimal modification. It has the optimized models, et cetera. So with that, I'll just say it also, we've already done it. You're going to see it today going across all these different execution providers as well. And again, there's sort of the details of what you get in the package. Again, this is all open sourced as well, all of it is. It's part of the end-to-end developer experience you're going to see across 4 different demos as we go through the rest of the day. So with that, let me hand it off to Yoyo, and she's going to show you a really cool demo.
Thank you. Awesome. Great, let's cue the demo. All right, my name is Yoyo Zhang. I'm a program manager at Microsoft working on Windows AI. In this demo, we will be optimizing the model with Olive, enable hybrid inferencing, and deploy cross-platform. Let's first take a look at the model. Today, we will be using the OpenAI Whisper Tiny and Whisper Large model from Hugging Face. The Tiny model is small and fast, making it a suitable choice for client inference. The large model is more complex. With that, you can achieve much better accuracy and result. So we'll use that for our cloud inference. Let's take the Whisper Tiny model, and then we will optimize it for CPU with Olive. You can customize the Olive optimization process to meet your specific needs by defining 5 key attributes that are used in the model optimization workflow. First here, you can see you can provide the model information. You can provide the host and target system, the evaluators you want to use, the passes you want to run, and the engine information. Olive will use the evaluators that you have defined to run the find and pass configuration parameters that are the best for the model for the target system. Now, let's take a look at the configuration we have actually created here for our Whisper demo. Great. Here you have the input model, which is the Whisper PyTorch model. We have set the target system we want to optimize for to the CPU. We're going to use latency as our optimization evaluator. And you can see here we have defined some passes that we want to run on the model. I won't be going into the full detail in this breakout session, but let me call out 2 very special passes that we have defined here that may be useful for you in the future. The first one you will see here is a beam search pass. Whisper model is a transformer-based encoder-decoder model. What that means is that when it is transformed, converted to ONNX without the Olive optimization, it will produce 2 models, the encoder and the decoder model. Here, we can use the beam search pass, and it will combine the 2 models back into a single model. Another pain point we often face when working with AI models is that there's pre- and post-processings that are required before we can enable the end-to-end scenario. Whisper model requires a pre-processing on the audio input to convert it to log-mail spectrogram, and then you also need post-processing to convert the output token back into the string. If you were to use the unoptimized version, you must also include additional code to handle the pre-processing and the post-processing before you can enable the end-to-end speech transcription. With Olive optimization, we actually have this inserted directly into your ONNX graph so that you get an end-to-end optimized model that is able to handle the end-to-end scenario. Lastly, you will see that we will define a few parameters that are meant for the Olive engine. Great. With all that defined, we are ready to run the Olive optimization in the command line. You'll see here that we're applying the passes that are defined in our config file. And let's take a look at the result. You can see here that we now have a single optimized model from the Olive optimization process. Let's take a look at the model in Netron. You can see here that the audio file is expected as input. We have the pre- and post-processing already included in this ONNX graph. We're combining the encoder and decoder model together through the beam search optimization that we defined earlier, and you get the end output as a string. We have done a performance analysis to compare our original model from Hugging Face to the optimized model that we just got from Olive. The optimized model that we have is more than 2 times faster than the original model when performing the end-to-end scenario to transcribe speech to text, from an audio file input all the way to the end transcribed text. The optimized model is also less than half the size of the original model, so this way you can minimize the disk footprint. With the optimized model, now we can add hybrid inferencing. Here's the C# Windows application we created. Let's add the optimized model we just got from Olive to the project folder. You can see here the application will perform the speech transcription using the Whisper models. In here, we will use the optimized CPU model on client when it is not connected to the internet. And when it is connected to the internet, we will use the large model. We do this simply by defining the CPU and Azure EP for each of the options. Great. Now let's set some breakpoints, and we will run the application. All right, we got our app here. Let's turn on the internet. We can load our sample audio file here, and we'll hit transcribe. You can see that the breakpoint is indicating that because we are connected to the internet, the execution provider is dynamically set to Azure EP, which will use the OpenAI endpoint on the cloud to run the Whisper large model. Let's hit continue. And we will get a result momentarily. Here we go. All right. Now let's go ahead and run the scenario again with the internet disconnected. Again, we load the sample audio file, hit transcribe, and you can see here, now because we're no longer connected to the internet, it is set to use the CPU EP to run the inference on client. Let's hit continue. And you will notice a very small change because the result is very similar, but here we have the local transcription result. Since the Olive optimization, the model produced is the end-to-end model that is able to complete the end-to-end scenario, we can actually deploy this model targeting additional platforms and cross-platform with very little code change. So here we have the Olive optimization model running on the browser using ORT Web. We can also use the ORT cross-platform support to deploy the Whisper model to additional platforms like Android. Here's another demo.
This app uses the Whisper model to perform speech recognition. Isn't that neat?
And you can see the local inference result. Great. As Jeff mentioned earlier, Olive and hardware-specific EPs can be used to make it easy to optimize and accelerate your models for additional hardware like NPU. So here, we're going to show you a sneak peek of the optimized Whisper model running on the integrated VPU from Intel's next generation platform, Meteor Lake, using the OpenVINO EP.
This is a test recording to demonstrate the capabilities of the Whisper automatic speech recognition model running on an Intel integrated VPU.
Awesome. Now we have the sample audio uploaded to the app. Since this demo is actually going to run the model on client using the VPU, I want you to keep an eye out on the VPU device utilization graph on the side for a little spike. Let's submit. Great. You can see that there is a spike that indicates the model actually ran on the VPU. And you can also see we have the text transcription output on the left here. Great. Let's go back to the slide for a quick summary. So here, you just saw using the Olive to create an optimized end-to-end model. Then with very little code, we can enable hybrid inferencing, completing the hybrid loop using ONNX Runtime and Azure EP. We deploy cross-platform with ONNX Runtime, and we were able to accelerate for additional hardware like VPU, use hardware-specific EPs. With that, I'm going to welcome Adele onto stage to tell you more about DirectML execution provider.
Thanks, Yoyo.
Welcome.
Hi, I'm Adele Parsons, a product manager on the CoreOS team working on DirectML. For Windows-specific devices, what if you could leverage the flexibility of ONNX Runtime backed by a hardware-portable API to deploy locally across the breadth of the Windows Silicon ecosystem? With the DirectML execution provider, you can do just that. ONNX Runtime and the DirectML execution provider offer a complete and powerful solution for developers like you who require high performance and low latency AI workloads across the Windows Silicon ecosystem. The DirectML execution provider is packaged as a part of ONNX Runtime's extensible execution provider framework you've heard about today. And it allows you to accelerate ONNX models locally in a hardware-agnostic manner. This means that all you need to do is optimize and integrate your AI models once, and they will run highly performant across the broad ecosystem of Windows hardware. The DirectML execution provider, or EP, is powered by DirectML, which is a low-level API enabling fine-grained control to optimize silicon performance and consistency. DirectML can improve evaluation time of models on Windows 10 and 11 capable GPUs without sacrificing that broad hardware support or requiring vendor-specific extensions to be installed. With Windows' wide-ranging hardware support and DirectML's efficient low-level API, you can take your AI apps to new heights of performance and efficiency. DirectML has proven performance on Windows GPUs. But what about emerging silicon like NPUs? NPUs are the next level of innovative silicon that will enhance your ability to deploy AI at scale. So let's see what next-generation experiences ONNX Runtime with DirectML is powering. Adobe empowers their users with AI across their suite of Creative Cloud applications. ONNX Runtime with DirectML allows Adobe to integrate fast and reliable AI experiences on Windows devices for existing and upcoming hardware. We are excited to showcase Adobe Premiere Pro's AI-powered scene edit detection and auto reframe features running with ONNX Runtime and DirectML on Intel's next generation platform, Meteor Lake, with integrated VPU. Let's start the demo. Often, editors will receive finished videos they must repurpose. In this case, I have a finished commercial which needs some more editing and to be reframed to post on social media. I'll start by right-clicking and selecting Scene Edit Detection. This feature uses machine learning to analyze a video and adds cuts when the scene changes. This makes it simple to begin trimming and rearranging quickly. You can see the workload ran on the VPU device, and now the video has been cut up so that each clip shows an individual scene. Next, we want to repurpose this video for social media and change the aspect ratio. I'm going to select Auto Reframe from the Sequence menu. The Auto Reframe feature leverages intelligent video recognition to identify the actions in your video and reframes the clips for different aspect ratios, all while making sure the subject of each clip stays in frame. We'll see this in action. These features are currently available in Adobe Premiere Pro. ONNX Runtime with DirectML enables developers to integrate their experiences seamlessly on Windows devices powered by next-generation silicon like Intel's upcoming Meteor Lake platform with new built-in VPU. Today, you've heard about the power of hybrid loop and how it enables cloud and edge scenarios. You've also seen how Olive and the ONNX Runtime's execution provider framework enhance the power of the platform by allowing for hardware-specific optimizations. Our platform enables you to write code that can be easily ported between different types of hardware without needing to worry about the underlying details of each device. This makes it much easier to develop AI apps that run on a wide range of environments from the cloud to the edge. In this morning's keynote, you saw how you can use Olive, ONNX Runtime, and the DirectML EP to produce one model that is highly optimized across the entire Windows Silicon ecosystem. It is clear that Olive, ONNX Runtime, and the DirectML EP will streamline and enhance your app deployment on Windows like never before. Now, I'm excited to show you an end-to-end example of the impact of leveraging Olive to optimize for the DirectML EP for hardware acceleration across the breadth of Windows devices. We'll then take that model and integrate it into a C# application and run it with ONNX Runtime and the DirectML EP. To truly highlight the hardware portability of DirectML, we're going to run this final app on both NVIDIA and AMD GPUs to really showcase the impact of the cross-hardware acceleration from the Olive optimizations. Let's start the demo. For this demo, we'll be using the popular image generation model, Stable Diffusion, to create the application you see on the right side of the screen. Let's get started with configuring Olive to optimize Stable Diffusion for the DirectML EP so our final app will work performantly across the breadth of Windows hardware and devices. The sample that you see here is available now on the Olive GitHub repository. As Yoyo explained, the Olive workflow consists of configuring passes to optimize for one or more metrics. Olive then executes each pass to find the best candidate model. To run a model through Olive, you need to create a configuration file with a few key parameters. Let's take a look at what is in the configuration file to optimize Stable Diffusion for the DirectML EP. First, we're going to specify that we're inputting the PyTorch version of the Stable Diffusion model. Next, we're going to specify the metrics to optimize for. You can see here we're optimizing for latency. Then we have the Olive passes. The first pass we have is convert to ONNX, and then the transformer optimizations, which will give us the speed increase. You can see that we'll convert to float 16, use the GPU, and optimize for the target provider, DirectML. Stable Diffusion itself is made up of a pipeline of 5 models. And so we have a configuration file for each of those 5 models to pass through Olive. To make it easier to manage these 5 models, we have a Python script to run each of the config files through Olive and target the DirectML EP. In order for this sample to run, I've already set up my Conda environment and pip installed Olive, ONNX Runtime with DirectML, and the other necessary libraries for this sample. So all I need to do is run this Python script with the optimize argument. When I run this Python script, the PyTorch Stable Diffusion models will be downloaded, converted to ONNX, and then the models will start to optimize for the DirectML EP. For the sake of time, we've sped up this process, which normally takes just a few minutes, but you can see that each of the 5 models have been optimized. Now, I have a folder called Models, which includes both the unoptimized and the optimized versions of this model. Now, let's get these models running in an application. Using the ONNX Runtime gives you the flexibility to develop applications in the programming language of your choice. Today, we'll be working with the desktop C# application. I currently have the unoptimized Stable Diffusion models in the app. So let's see how this runs so we can compare the time it takes to generate an image before and then after the Olive optimizations. You can see in the task manager that I'm running this app on an NVIDIA GeForce RTX 4090. I'm going to run the unoptimized Stable Diffusion models through the app. And what I'm going to do is run this 2 times, because the first time that we run a model, there are always some initialization costs. But you can see that the model is running locally and utilizing the GPU. It took 8 seconds to load an image. Note that the total time includes the inferencing and all of the C# app components, while the 6.4 iterations per second is just the inferencing of UNet, the main model in Stable Diffusion. Now, I have the same version of this app with the Olive optimized models we just made. I'm generating twice for an even comparison, and now we see 1.3 seconds, which is over 6 times faster, thanks to the Olive optimizations. The great thing about DirectML is that you can use Olive to use the same optimized models, and they'll run automatically with high performance across the breadth of Windows devices. To highlight this, I've switched over to a machine with an AMD Radeon RX 7900 XTX. I'm running the same unoptimized models first and doing 2 runs. We can see it takes 10 seconds to generate an image. Then let's run this app one more time with the same Olive optimized models that we just created. I'm going to run twice again so that we get an even comparison. And now we can see a speed up again, 2.8 seconds, an incredible 3.5 times faster from the Olive optimizations. All right, now you've seen an example of how to use Olive to optimize for the DirectML EP for hardware acceleration across the breadth of Windows devices. With Olive, you can optimize your AI models to leverage the full potential of DirectML's cutting-edge AI technology, harnessing the power of GPUs and upcoming NPUs. You can then take those highly optimized models and deploy them in a Windows application with ONNX Runtime and the DirectML EP, unlocking top-tier performance and flexibility across the diverse range of devices in the Windows ecosystem. Truly, with Olive, ONNX Runtime, and the DirectML EP, the next era of AI is here, and the possibilities are limitless. Now, back to Jeff to recap all the exciting new features you heard about today.
Thank you, Adele.
Thank you.
So a couple interesting things you saw. One is a massive speed up you get with optimized models. The thing we don't mention is there's almost no accuracy loss as well as we quantize them down and get you not only the speed up, but the smaller model size, so it's easier to load. Oops, I think I went the wrong way. So I kind of want to highlight a couple things. One is we've also made ONNX Runtime as the gateway to Windows AI. You've probably heard this in Panos' keynote. You've heard it. You've now heard it here. You'll hear it again later in some of our other sessions I'll mention in a bit. But the other key piece of this is the exact same tools, the same tool chains that we use internally, that Microsoft developers use to power AI throughout all of our apps, all of our services are now made available to all third-party developers. And that's huge. It's the same ones we've proven the scale, proven the performance on. We're now exposing them everywhere globally. And again, ONNX Runtime, Olive is all open source. The other aspect is it's also extensible. You can create your own custom EPs. You can go to Olive and create your own optimization techniques and integrate them into that project. So all of this is open and available. So with that, let me talk about why do you care a little bit about this is, one, ONNX Runtime's portable. I can go across to iOS, Android, Linux, Windows on ARM with it with minimal changes as I move across platforms. I can go hybrid. I can use DML to abstract across, so I optimize once for the whole Windows ecosystem today with GPUs, and coming soon, or coming in near future, is across all NPUs as well. With Olive, I can now do hardware-aware, extensible optimizations on my models. Send them in, create a configuration file, it spits out a package I can then integrate into my application that gets me the best performance on that hardware. And then lastly, we've added this hybrid capability with the Azure EP. You saw it going to OpenAI Whisper in the cloud, and it goes local. We showed you, for sake of ease of demo, connectivity as the trigger, but there's so many other ways to think about how you could do this. If I'm in control of my app's experience, maybe I have a gating model that says, hey, based on this input, I really need to go to the cloud for the best results out of this, and therefore I'll do that. Or maybe it's other conditions, I don't know. Maybe I have low battery life on my local device, so I want to shoot it to the cloud and bring the results back. You get to decide. It's all in the developer's control to decide at runtime which way I want to go. And it's as simple as sending in a different flag to, do I want to go Azure or to the cloud to Azure, or do I want to go locally to inference here? And again, it gives you control of security, gives you control of privacy, really puts the power to you. The other aspect that we really haven't touched on much is, because this is open source, because this is behind all of Windows and all the services that we're using at Microsoft, it's pretty much future-proofed. It's open source. You can contribute to it. A bunch of the other ecosystem players contribute to it as well. Pretty much, I'll say all of the independent hardware vendors and or silicon ISVs that you saw listed here contribute to both of these projects, because they want the AI to run the best through Olive and onto the ONNX Runtime environment. So it really gives you all this great flexibility, cross-plat, cross-silicon, hybrid across cloud and edge. And it is now the gateway to Windows AI. So the other thing you saw perhaps earlier today was the introduction of Dev Home. Both Olive and ONNX Runtime are now also integrated with Dev Home as of this week, and will continue to be integrated, which allows you to easily set up your environment to use and or contribute to these projects. And then later today, if you have further questions, we're going to deep dive in the discussion session at 4, where we're going to have very little overview, a demo that's going to be shown to kind of ground everybody who maybe missed this session, and then it's 30 to 35 minutes of Q&A, whatever you want to ask. I've got the developers from Olive, from DML EP, from QNN EP, from Azure EP, from ONNX Runtime, on the line, either in person or on the hybrid or online session, to answer any question you have. Then if you really want to get hands-on, we have 2 hands-on coding sessions, which will walk you through actually deploying and implementing two different sessions. So at 2:45 or 4 p.m. today, and you'll realize the 4 p.m. does compete between those, so choose wisely. You'll be able to do hands-on and actually implement 2 different apps throughout this. And then if you want to use the QR code here, you can hit that. If you also want to see, I'm saying don't hit that QR code. Instead, go to ONNX Runtime, ONNX.AI, WAC, lowercase b, UILD, 2023. Build 2023 at ONNXRuntime.ai, and you'll get all the blogs that were posted and the code repos for all of the demos you saw here today. And with that, do we have any questions? You can use the QR codes here. I think we have some online. Yes. So let me read it out. Can you talk a bit more about your evaluation metrics? Which ones are available, and can you use custom ones? So I think that might have also been answered in the chat. But yes, I assume they're talking about Olive. Here is you can yes, you can add. As I mentioned, it's an extensible framework. It's an open source project. You can contribute your own custom ones as well. There's also, if you look at the documentation out there, again, we have links to all of that. You can also use the standard ones that are built into Olive itself. So all of that, and we can go into that in a bit more detail in either the discussion and or the hands-on lab this afternoon. Was there any more online? Otherwise, we do have time for 1 question live from the audience, maybe 2, if anyone's bold or brave enough, so I don't have to make up a question on the spot. Otherwise, we only have 2 minutes left and we can wrap. So, okay. All right, let's go. It's an open source project. You're free to use and run. So sorry, let me repeat the question because for those online. The question was, is there any price for utilizing, I assume, ONNX Runtime or Olive when you run it locally on your machine? No, it's an open source project. You can go build it or take pre-published packages and utilize them as you will. Obviously, I will step back and say, if you use Azure EP, there is still charges for it. You have to have your Azure subscription to call Azure. But other than that, it's all free to use. And again, that's why we built it this way, so you can use it wherever you want, everywhere, and just try to make it easier for the end-to-end experience as you deploy AI. All right, thank you, everyone.